So in this video, we're going to introduce the lab part for NumPy. And as we mentioned, NumPy is one of the fundamental modules for anything related to data processing, like even image processing, or data sciences, data analytics. So let's get started with NumPy. NumPy is basically it's dealing with the n-dimensional data that is in the same data type. So it uses array to manage all the data. So it can be dense, continuous, uniformly sized block of identical data type. So let's first get started. You will first use this line import NumPy as NP. So this basically will give you the actual NP. So that's why you use NP all the time. And so for example, we have a list. So this is a list. Some people may say, okay, I can use list while I'm using array, right? So I'll show you the difference. And we have list right here. We have array used as NP array. And then you're going to see A basically has a different shape. So if I run this, you will see A is like this. It's pretty much same thing like this. However, it has the keyword array in it. And then when I print the list is going to look like this, and A is look like this. So you will see, okay, it's pretty much similar, right? Pretty much similar. But the data types, they're different. One is actually the list. The other one is the ND array. N-dimensional array. ND means n-dimensional array, ND array. So this is the and the data arrangement or the data in the memory is actually quite different. In the list actually has two layers of the arrangement. It's like a tree structure, right? For list, I have, for example, I have rows. This is row. This is second row. And those are the columns, like 0, 2 is column 0, 1, 3, that's column 1. Okay, so I have those. When I have L list 0, that means we're going to retrieve the first row, and then the column 0 and column 1. When row is 0, column is 0, that will be our first elements. When row is 0, column is 1, that will be our number 1 as these elements. When I am looking at the second row, and then I have 0, column 0, that will be my 2. Column 1, that will be my number 3. So this is how the data is arranged. It's like a tree structure, right? We call this actually linked list. So it's like a list. And then, however, for array is basically give you the whole block of the memory. And this piece of memory basically just put those 0, 1, 2, 3 over there. And they're concise. They don't have lots of pointers. So that's how the memory is put. So in the standard Python interpreter, the return value of ID is the memory address of the project. So when I actually run this one, you will see the address of this one is this. And when I do this list, you will notice that the rows are actually far away. Even I only have like 4 integers. They're very sparse, right? So if I run this, you will notice that for those lists, they are actually the columns are not so much, but it's still 32 bytes. They only show you basically the address of this one and this one. They're next to each other, and this they're next to each other. So every row data, they're putting the data to each other. You may ask why we matter about this, because this is actually make it easier to access the list. However, use NumPy, we don't even need to be worried about those. We simply just to do the job, be focused on the job. We can create a NumPy array simply. So let's assume we're going to create some random numbers. We first use the random seeds. Why we use the seeds? Because we want the experiment to be able to repeat every time when we did the experiment, right? So the random number in Python is actually called pseudo-random. So that means that they are actually it's random in a certain way. However, it's not fully random. It's controlled random. So we can like this one is a good example. If I give you the same seed, it's going to repeat the same sequence of the random numbers. So I have a random integer numbers. Here's what I'm saying. I am going to ask the random numbers are between 0 to 10, to up to 10. It's actually 0 to 9. And then the size is going to be 6. So it basically means give me 6 random numbers between 0 to 9, including 9. So it's one-dimensional. And the x2 is actually saying, okay, I am going to have all the numbers between 0 to 9. However, my size is 2 by 4. 2 by 4, that's actually a two-dimensional array. So this array is going to be, I have 3 rows, 4 columns. 3 rows, 4 columns. That will be my two-dimensional array. X3, that will be another two-dimensional, actually 3-dimensional array. So it's again give me 3-dimensional array. I'm going to have a 4 by 5 array, 3 of them. So give me like a 4 by 5 array. I need 3 of them, 3 of 4 by 5. So that all the numbers actually are between 0 to 9. So this way we can print out all those numbers. You will notice that's my x1. This is my second x2. And the third one is going to be like 3 of 4 by 5. So each of those has 4 rows, 0, 1, 2, 3. And 5 columns. So 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. So I'm going to have like a 3, 4 by 5. And so you can actually find the dimension, the shape, the size, the data type, the item size, and the number of bytes. So if you check, you're going to see this, right? You're going to see this. So each item is 4 bytes, and you have 4 by 5. That's 20 times 3. That's 60. 60 times 4. That will be 240 bytes. So that makes sense. And the data type is int 32. That means it's actually 4 bytes, 32 bits. And x3, the size of x3 is 60 because it's 3 by 4 by 5. That's exactly 60. The dimension is actually 3 dimension, right? I have 3 dimension. So that's kind of understand what is the data actually look like. And now we're going to use ND array and NP array. They basically are the same thing. You can use ND array, so they're basically the same thing. A is actually a array it's one-dimensional array, has 1, 2, 3, 4, and the data type of this one apparently is going to be int 32, and then you can check what's the dimension. It's 1, and a shape, again, that's going to give you what's the shape. It's actually the top. You can reshape it to 4 by 1, and then you can reshape to 1, 2, 3, 4 by 1. So it's going to give you similar things. So here, if I'm printing A, that will print it out. You can reshape, right? Reshape it. So this becomes NP array. Okay. So let's take a look. The itemized NumPy. How do we initialize the NumPy? And suppose I have an array that is M, and it has 1, 2, 3, 4, 5, 6, 7, 4, 5, 6. So this is it, right? And then when I print the type, it's going to be a floating. Even I only have one floating number, it's going to treat everything as a floating. And the shape is going to be 2 rows, 3 columns, 2 by 3. And if I want all zeros, then I can simply just say all zeros, and then all ones. So that will be all ones, or identities. They're all of those. So you can actually print all of them. So like print Z, print O, and print I. So let's run this again. You will notice that I actually have all those values now. All those values. So this is a big 10 by 10. It's a 10 by 10 0, and this one is actually 5 by 10 ones. So 0, 1, 2, 3, 4. And the last one is identity of 3. That means it's going to be 3 by 3 identity matrix, right? And then the print z.type, it's going to give you the z.type, right? It's the z.type. Okay. And the next one, you can actually, here I resize it, right? I change it. I change to the type, a different array. So it's actually give me a different array. Now let's come to an important concept of NumPy array. NumPy actually can be indexed and sliced, a lot like the Python list, but they actually take tuples of values to reference each dimension. So if you only have one dimension, therefore you are only going to have one tuple. If you have 2 dimensions, depends on how many rows you're going to have, then you're going to have n tuples. So the basic slicing occurs when the object is a slicing object. Actually, you are going to see the way we slice it. It's going to be start, stop, and step notation. So here is an example. Suppose we have an array like A, B, C, D, E, F. So when the index from the top, from the front, so we starting from A and go always all the way back to F. The index will be 0 to A, 1 to B, C as 2, and the 3 as this one. The D will be number 4, and the 5 will be right here. So when we are actually indexed from the rear, so the index of this one will be 1, the index of this one will be 2, the index of 3 will be this one, index, that's the index, right, and so on. However, when we do the slicing, so when we say column then 1, that means we are starting from 1, and then we here's the index. So when we have slicing 1, that means we're going to only retrieve A. Slice 2, that will be only B. Slicing 3, that will be C, right? From A, B, C. If the front is empty, is nothing, then that you're gonna get from the very first elements to the number 4, and so on. So you're gonna do that way. However, the tricky part is the slicing from the rear. So when you are slicing from the rear, let's say you actually starting from -1, that will be F. So F has the index of -1 or -1, so that means this is included. So -2, that will be E. Same thing, it's your index is -2, and so on. You do the same thing. Suppose I have another array. I have 1 to 10, and you will notice this is actually my index, and then this is actually my index from the rear, right? From the rear. This is index from the front. So let's take a look example. In this one, my array is 0 to 9. So I have about 10 elements. And when I am doing the slicing, so what does this mean is I started from 1. So 0, 1, I'm starting from this one. I stop at 7. So 7, that will be exactly this one. So that will be from 1 to 7. However, my step is 2. That means I'm going to print out 1, then I'm going to skip 1, and then print 3. So it's 1, 3, 5. Do I have 7? I don't, because this is up to 7. So this is from 1 to up to 7. So that will be actually number 6. So I am going to have print 1, 3, 5. When I next value is supposed to be 7. However, I am stopping at 6. So the value will be 135. Right? 135. What if I'm doing reversely? As we know, the index of this one is -1, -2. So when I have -2, that means I am starting from 8. I am starting from 8, and I am ends at 10. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 9, up to 9, up to 10. So that will give me starting is 8, ends at 9. So the value for this one is going to be 8 or 9, 8, 9 for this one, right? 8, 9. So starting from 8 and then ends at 9. So that's the one. So let's say, what if I am going to have this one? So I am starting from -3. What is the -3? That will be -1, -2, -3. So that will be starting from number 7 and ends at 3. So that will be right here up to this one, up to 3. And then I am going backwards. So I'm going to print 7, 6, right? 5, 4, up to 3. So it's not reaching to 3. So that will be exactly this up to 4, right? At 4. So 6 and 5, 4. So that will be the value. And then the next one, we are going to do, what if I am going to starting from number 5 and to all the end. So that will be starting from here to the all the way end, right? So let's see if this is gonna be 5, 6, 7, 8, 9. So starting from 5 to the all the way end. What if I have 1, 1? So that means I am going to retrieve starting from 1. Starting from 1, it's not this one, right? This is 0. Starting from 1 ends at 1. So that will be actually, where is my 1, 1? right here. So that's actually, it's going to be empty. That's going to be empty. You start at 1, you end at 1. So that's ends up to 1. So that's actually empty. So this one is a little tricky, okay? And then for the next one, we're going to do is, suppose I have m11 and then m0 minus 1. So this one was actually, I start, oh, this is actually a different array now, right? So this one, earlier here, we stop at the one-dimensional array. Now I am doing the second dimensional array. So I have m is running as m is run as a two-dimensional array, and that will be 0, 1, 2. And then here I am going to do this 1, 1, starting from 1, ends at 1 for m, and therefore it's going to be empty. And then, however, if I am going to do this this kind of indexing, this means a row. The first one is row, it's number 1, row number 1. So this is row number 0, row number 1, and then y or column is number 1. The column is going to be number 1. So which will be this elements, right? It's going to be this elements. That's for this m11, m comma 1, and then for the second one is going to be row. It's going to be 0. Column is going to be -1. So what row is 0, the column is -1. So that will give us number 2. That's exactly right. Okay. So, and sometimes we may say, okay, this is going to be, the row is going to be 0. Okay, the row is 0, so which means this row. And my column is going to be from 1 to the end. So that will give me 1, 2. 1, 2, right? That will give me 1, 2. And the next one is, what if I am just missing something, right? I am going to print those ones. Missing the indices are treated as a completed slice. So this one, if I only have a row, I don't have columns, it's actually will print the whole thing for me. It's going to print the whole thing. It's just like a the row number 1, the row number 1. The columns will be everything. It's same thing as this one. It's identical. Those two. And suppose I have another two-dimensional array, and then I'm just trying to align them nicely. So it's easier for us to read. Suppose I have another two-dimensional array. You may say, hey, how do I know it's a two-dimensional array? Because notice here you have two brackets. So this is a 1, 2, right? And in this two-dimensional array, you have 0, 1, 2, totally 3 rows, and columns 0, 1, 2, 3. So totally 3 rows, 4 columns. So it's 3 by 4 array. So in this one, we are going to do the slicing. This is like exercises of the previous ones we actually practiced earlier. So now I'm going to test if you can do this. So I have a two-dimensional array, and my row will be starting from 0, ends at 0. So my rows will 0, 1, 2, right? Starting from 0, ends at 1, at all of it. And then my step is 1. So that means going to have everything. However, my column is going to be 1. So that's 0, 1. So the output is going to be 2, 9, -3 for this one. Am I right? 2, 9, -3. That's exactly right. And then for the same thing here, I am going to have all the rows. However, the rows actually is not all the rows. It's actually all the other rows. So starting from beginning, ends at end, and however my step is 2. That means I am going to do this row and this row, and my column is 1, so I'm going to get 2 and a negative 3. 2 and a negative 3. Oh, it's this one. 2 and a negative 3. That's the answer, okay? And the next one, access the subarray of X. So what this means is I am going to have 0, 1, and then, so 0 to 1. 0, 1, and then my column is going to be 0, 1, 2, right? So 0, 1, 0, 1, and the columns 0, 1, 2. So that will be a small matrix. It's just like the first 2 rows, and then the first 3 columns. So that will be our array. So you see, that's the first. It's just a section of it. Sometimes when we don't put anything there, we just put a 0 there. That basically means NumPy will fills the trailing slices. If we don't supply as many as indices, it will actually are all the dimensions that are in that array. So this is x0. It's same thing as x0. That means row 0 and all the columns. So that means row 0 and all the columns. So that will be basically the first row, all of them. And sometimes we can use slice none and the number 2. The x will be, this is row, right? Row will starting from 0 ends at 2, however not including 2. So that will be 0, 1, and my columns will be 0, 1, 2. Ends at 3 and not include 3. So this is basically it's going to print 0, 1 for this x. So you're going to have 0, 1, and then column is this. So it's pretty much same thing as this one, what we just saw, right? So this is going to be the equivalent to this one. Okay, that will be the output. And the same thing, we can actually use this 1, -1. So it's basically same as 1, -1. So the rows will be 1, columns will be -1. So that means -1, which will be number 3, right? 0, 1, 2. Actually, it's going to be number 2. So here's this. So columns 0, 1, 2, 3. -1 will be this column. And the rows are actually 1. So that means we're going to get the row 1, this row, and the column is this one. So we only get number 8 for this particular example, right? For this particular example, if we will run it, only get 8. Okay. Now I am going to I can assign my m again, and then that will be the whole, still reassign the values, right? I can do this way, so it will align. And advanced slicing for integer. In this example, we're going to have one-dimensional array, and we can simply just print the just indices 2 and 5. So I have array A, and when I want to print, so 0, 1, 2, from 2 to 2, this is a 2 and 5. Remember, this is actually a list. So I only want to print number 2 and number 5 indices, right? So 2 and 5. So that will be 4 and 25 will be selected. And when I have another array, that's array, and then I have array of another array, you see that? And in there, it's actually a 3-dimensional. So because I have 3 brackets, you see that? 3 brackets. So what this means, give me 2 of 3 by 1 array. So this is the 3 by 1, 3 by 1, and the 3 by 1, right? One of the 3 by 1, 3 columns, 3 rows, 1 column. So you can think about this actually reads like this. Okay. So this is another one. Okay, this is actually 3D matrix, 3D matrix, 3 by 1. And then when I want to slice 1 to 2, well, you know, this one is when we only have the 2 objects, but there are actually 3 dimensions. However, you only specify like 2. And it's actually will print out is actually so for the matrix is going to be the second matrix because this is 1, and then it's going to print out the whole matrix. It's going to print out the whole matrix. So 4, 5, 6. That's how do you do? Just because this number is less than the number of the dimension. The dimension is actually 3 by 1. Here you give me a 2. 2 is less than the 3 by 1. So 2 is less than 3. So it's basically going to give you the whole 3 by 1 array. Ellipsis means we're going to expand the number of the objects from beginning to the end. So what it means, the rotation is actually 3 dots. Basically means all of it, right? So it's equivalent like this, slicing all of it, something like this. For example, I have x we defined before earlier here, right? And let's redo this one. Let's print it. My x is like this, right? My x has 2 by 3 by 1 array. And when I am doing this, that basically means I am gonna take only the 0 columns, the zeros columns, and it's gonna be for those arrays. So that will be 1, 2, 3, because they are all 0 columns. They're all in 0 columns. All the rows, and that will be my first one. And for the second one, all the 0 columns, all the rows, but it's in 0 columns. That will be 4, 5, 6. That will give us this array. So this is kind of like equivalent to somehow equivalent to something like this. If I have a simpler, so when I want to do this example means x, so in this case x is, I can print out what's the x value is, and let's run again. You will notice x is still this, but what this means is you're gonna have all the rows, so I'm gonna have 2 of the 3 by 1. However, I only interest about my 0 columns. So since this is the 2 of those 3 by 1, so I have 2 rows, and for each row I have number 0 column, so that will be my number 1 and number 4. So that's here. And then you can also use this ellipse 0. That will give you somehow equivalent to this one, ellipsis. Just trying to show you this one is the ellipsis is same as this because that's exactly the rotation of ellipsis. Okay. For the slicing, the Boolean slicing, what does mean is you are only going to use the true value in the Boolean NumPy array, and only the true value will be kept, or the false value will be skipped. So speaking of that, let's first print what's A, and then we print what's B, what's A is greater than B. A, look at A is 0, 1, 4, 9, 16, 25. Here says A has to be greater than 4. That means we're going to take out every single elements and compare with number 4, and we record what's the Boolean value. So is 0 greater than 4? False. Is 1 greater than 4? False. Is 4 greater than 4? False. Is 9 greater than 4? True. Is 16 greater than 4? True. 25 is greater than 4? True. So that's how do you get the Boolean NumPy arrays. And now the interest part is now I am going to use the Boolean array to filter my data array. So you will notice only the true will be only the value that has the Boolean value of true will be kept. All the others has been discussed. So here's another example assignments for the slicing. Suppose I have A is right here, and then I am going to do A of B is assigned by 0. So B will be this this value, right? And then what is this? So that means I am going to assign all the elements, each of the elements I'm going to overwrite. I'm going to show you all of this. So now if I print A, B, you're going to see the A and AB is going to be all 0. So that basically means 9, 16, 25 are overwritten by 0. Okay. However, A's value, you will notice that it's very interesting. A's value now being updated. So that means if you actually updated all of the A's value. Another example is suppose I have A, B, C, D, E, F, A, B, C, B, A as array, and then here says S is not equals to A. So that will basically go compare every element. So this is going to be false, true, 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 false. And all of those are assigned with Z. So what is going to be S's value? So remember earlier when we said true, this is false, true, true, true. So only the true value will be updated by 0. So you will see false, true, 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 false. So that's exactly what's the reason right now. Next part, I am going to do the array view and copies. So we're going to keep on working on the views of the NumPy array. So we have suppose we have an array that's looking like this. All right. So I'm gonna just format it a little bit better so it's easier to read. So apparently this is the 3 by 3 array. You can understand it as a matrix as well. So 3 by 3 matrix. And then I'm going to just simply just assign to another reference. And then so A is B. So A is B. So I'm going to test if A is B. Okay. So this will actually shows you it is true. It is true. So basically the two things is the same. Remember in the earlier we have a chart shows you how the memory is located. So you basically has A is here. Now you said A is referring as B. So B is also pointed to the same place. A and B pointed to the same place. So that's why when you are testing A is B, it's giving you true statement, right? So that's why it's here is true. Now I am gonna change. I'm gonna change for B. So row 0, and column 0. So I'm gonna change this to 1000. So will that affect A as well? It sure do, because they share the same piece of memory. If you change one place, it's gonna make the change for the other one. So, however, if I am going to do a slicing, let's say I'm doing the row is 1 and the columns all of it. So I basically retrieve the row 1, so 3, 4, 5. This is gonna give you 3, 4, 5, right? 3, 4, 5. And then row, for this row, I am going to change number 2, 0, 1, 2. That means this one I'm going to change to 5,000. I'm going to change to 5,000. So, and then you will notice that it's actually changed A as well. So even this is just one section of this. So you can think this is like a box, like a frame. I use the frame to place on the original matrix, and it's when I change one of the value, it's changed the place in the memory. So sometimes you want this kind of shared memory, sometimes you don't, right? Sometimes you don't. In that case, you will have to make a copy, make a explicit copy. You can do new mat equals to new matrix, right? Matrix is equal to a.copy. So in that way, new matrix is going to be the copy. Then you just update the very first one from 5,000 from 1,000 to 0, and a value will not change. A will not be changed. However, new matrix will be changed. So if you check this one, it's changed. So there are two copies, two pieces of memory now. So there are some advanced slicing copies. For example, if I have array, like same array, 0, 1, 2, 3, 4, 5, 8, right? 6, 7, 8. Now I'm going to say A is greater than 4. So that will be false. This will be true, 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 true. All the others will be false. Now I am taking A, taking this one as this. So all the others will be eliminated. So the B will only be 5, 6, 7, 8. It becomes one-dimensional array. And then I am going to assigning -1 to all of those values. Then my B's value is going to be all negative ones. Now let's look at what is A's value. A is not changing at all. A is not changing at all. However, when I have A is greater than 4, becomes -1, then it will change all the values of this. You see, this is kind of interesting. When you actually are doing this, this is actually make a slice copy without affecting A's value. However, if you directly do the operation to A, it's actually permanently change the A's value. And another example is, suppose you have A as a matrix and you're calling a function, and in the function sets all the value of the elements to 0. This will actually change all the values of the array to 0. So you see A becomes all 0 now. Now we're coming to the functions and on array. So if you want to know all of the functions, roughly about 400 functions, you can go check this link, and it's gonna give you all those functions. There are so many functions. It's in mathematic functions. You can find a lot of those. But however, we're going to do this. We're just showing you a few ones that we often use. So for example, if I have an array as 1, 2, 3, 4, I want to find what's the mean value. Then when I run it, it's going to be 2.5. What's the summation of those? 1 plus 2, that will be 3. 3 plus 3, 6. 6 plus 4, that will be 10. So ideally, we're supposed to get 10. And then what's the sign of A? So basically, we're going to apply sign to every single one of the elements. So that will calculate all the values for you. And you can do element-wise addition. So suppose you have array, like only have 2 elements, and when you do add, it's gonna add those 2 elements together. If we generated 2 arrays, this means we're gonna generate a array from 0 to 9 and the shape to 3 by 3 two-dimensional matrix. That's what our x1, and x2 will be from 1 to 0, 1, 2. That will be a matrix x2. So this one is from 0 to 8. This one is from 0 to 1, 0 to 2. So that will be our matrix x1 and x2. When we add them together, that basically we're adding x2 to every single row of those x1. So we add x2 to every single row. So that will be the results. Same thing when we are doing, we can use the symbol, use the notation as plus. That will runs the same results. And the same thing, we can calculate what's the reciprocal of a value. Basically is it's 1 divided by this number, right? So 1 divided by 2, that will be giving you 0.5. And the same thing, if your matrix is bigger, it's gonna do element wise. So it's 1 over 1, that will be 1. 1 over 2, that will be 0.5. 1 over 3.3, that will be roughly about 3, right? So same thing for the positive and negative. If you have an array, when you do positive, they basically don't change anything. But when you do negative, it's flipping the positive and negative signs. For multiplication, it's similar. If you have, it's like the other ones. It's gonna do the element-wise multiplication. If I have one matrix x1, the other one is x2, when I do multiply, that will give me the element-wise multiplication. And then, so when I have NP array number 5, that will be x. And then when we are doing the true division, and you are going to see this one is actually divided by every single element is divided by 4. So that will be the results. That will be the results. You can do the same thing. X is a one-dimensional array, and then when you are dividing by 4, it's a true division. It's give you the same results. And here is actually double slashes means the floor division, right? When you do floor division, it's basically you take the floor and only the value, the results is greater than 1 will be kept. For power, it's about the same. So when you have one range of power, you can do the power of, in this case, is power of 3. So the range of x1 is going to be from 0, 1, 2, 3, 4, 5. And then when you do the power of 3, it's every single element is going to do the power of 3. Same thing for x2. If you have x2, then it's going to do like a paired 1 by 1 and do the power. So x1 to the power of 2. So 0 to the power of 1, 1 to the power of 2, 2 to the power of 3. That's exactly what you're receiving. Okay, you can write like this way too. And then for subtraction, it's the same thing. When you are doing the x1, x2, it's gonna do element-wise subtraction, right? Same thing. You can use the notation subtraction. Next one is we're gonna talk about the axis. Most aggregation operation take an access parameter to limit it, that limits the operation to a specific direction. So axis 0 normally is the rows. Axis 1 is normally is the columns. So in this case, we're gonna say, okay, I'm gonna have NumPy a range. That means from 0 to 11, 0 to 11, totally 12 elements. Reshape to 3 by 4 matrix, right? Two-dimensional matrix. That will give me this matrix. And when I do summation, when I do sum, it's gonna add every single elements. However, if I am going to do axis 0, 0 we said it is row. So we're going to do rows. You're gonna see we're gonna receive 12. So that X means is the cross rows. That means actually add all the columns. It's cross rows, cross rows, cross rows, and so that will be give me 12 for the first one. So this one plus this one is 6 plus 9 is 15. That will give me this one. Same thing. When axis is 1, that means it's cross columns. So let's run this one. It's gonna give me so this one is gonna give me the results of this. So cross columns. So 1, 2, 3, 0, 1, 2, 3. That's the columns. So when you add those numbers together, that will basically give you number 6. Cross columns 4, 5. That will be 9. 9 plus 6, 15. Plus 7, 22. That will be 22. Same thing for this one. Others, you can do data normalization. How would you rescale your data range from 0 to 1? And how would you rescale your data from to 0, mean and unit standard deviation, STD, right? So you actually can do something like that. We actually have a data for you, so you are ready to actually process that data as assignments. So for example, we can get gene from the text. Gene from text is actually simpler, is the same thing as load text. Is actually same thing as load text. It's really delimited files. So if I run this one, you're gonna see I have a bunch of lines because it's now to recognize the default space delimiter is gonna be the white space. However, in this CSV file, the delimiter actually is the comma. So when we specify as a comma, it becomes a lot of lines. Nan means they are very small numbers. It's like a minimal numbers. However, it's not 0. It's very small. We can actually load the data. We can load the data and then we can do the assignments. So if I load the data, you will see if I'm loading as a string, it's going to be like this, right? It's going to be like this. Earlier, you will see there's a bunch of none because they're small. They're kind of small. It's cannot recognize it correctly. However, we're going to read it as a string and then we can process it, right? We can process some of the numbers, like because some of those they're big, some of them are small. So that'll give us the problems. So we load it as an integer and then we load it as a string, and then we're gonna parse this one as the header, and all of those are as a gene data, right? Gene data for different times. So let's say this is the value. Now I can actually access each of the value and find what's the value, and then I can if you are interested, you can actually find what's the gene from text. This is actually, you can read the help. If you run it, it's going to give you a list of the methods. It's one of the modules. Okay. And for the assignments, we're gonna do express the data. We're gonna read the data, and then we will be able to plot the data. So to plot the data, we actually need some of the preparation, so that will be our data. So it's called the S data, and it's same thing as Spellman, and we will do that in the next session.